nuclear bomb can annihilate an enemy in a flash but, perhaps more importantly, also allow a state to flex its muscle on the world stage. So far, just 8 countries have officially detonated nuclear weapons, but others are suspected of owning them or trying to develop them. Iran is currently top of that list, despite the country's continued protestations that its nuclear program is for peaceful purposes only. Although the technology has been around for decades, becoming a nuclear nation is no easy task. It can involve smuggling, deception and years of hard work, not to mention the threat of swift retribution from other world powers. So, what does it take to build a nuclear bomb? And why do few countries bother? BBC Future lays out the challenge and peril of any country wishing to undertake its very own nuclear weapons program. Step 1. Choose your isotope. Any aspiring nuclear nation will first need to gather its scientists, engineers and technicians. This team will know all things nuclear work on a simple principle. When a heavy nucleus of an atom splits, it converts a tiny amount of mass into pure energy. That energy can be used to treat cancer, generate electricity or level a city. Nuclear blasts are triggered through an uncontrolled chain reaction in a large block of material, where each new split causes more splits, releasing more energy. Fortunately, most radioactive materials cannot sustain chain reactions. The most common isotopes that can are uranium-235 and plutonium-239. Plutonium-239 is the stuff of choice for the big boys, like Russia and the US, but it doesn't exist in nature. To get it, countries need to make it inside a nuclear reactor, and nuclear reactors are hard to hide, says Jeffrey Lewis of the blog Arms Control Wonk. Stealth is what is needed in the early days of a nuclear program, so uranium is the natural choice for most countries. Step 2. Get some uranium. Sounds tricky, but it's actually the easiest step in the entire chain. Uranium is mined commercially all over the world and is sold in a powder form called yellow cake. Some countries, like Iran, choose to go it alone and mine and process its own yellow cake. Others simply go to the world's biggest supplier, Kazatomprom, Kazakhstan's nationalized nuclear power, which exported nearly 20,000 tons of uranium in 2011, according to the World Nuclear Association. Unfortunately, buying in bulk has its drawbacks. Kazatomprom's uranium is mostly uranium-238, a naturally occurring isotope that will not sustain any nuclear reactions at all. Just 0.710% is the uranium-235 needed, yet the simplest nuclear weapon requires about 50 kilograms of 90% pure uranium-235. As most countries will want 2 or 3 for testing and redundancy, it requires around 150 kilograms 330 pounds of uranium-235, or around 20 tons or so of yellow cake. On delivery it needs to be stored, which means a country need to think about building a nuclear complex. Iran stores it at the Isfahan facility, south of Tehran, whilst Iraq's former leader Saddam Hussein kept his at Tuwaitha, south of Baghdad. Step 3. Begin processing. Saddam's yellow cake was useless, but then so is everyone's. To get useful uranium-235, a team will need to first separate the isotopes. It's trickier than it sounds because chemically speaking, uranium-235 and uranium-238 are identical. The only way to separate them is by their mass. 238 has 3 more neutrons and is therefore a tiny bit heavier. The most efficient technique is to spin uranium inside a centrifuge, but spinning uranium powder will make a mess. To get yellow cake into a more useful gaseous form, a team of researchers in white coats follow a simple recipe: heat it to burn off impurities, then expose it to hydrogen fluoride to make uranium tetrafluoride. Heat the uranium tetrafluoride again in a kiln filled with fluorine gas, and with a bit of luck out will come gaseous uranium hexafluoride. It is a very corrosive and dangerous chemical and needs to be handled with care. Step 4. Steal some parts. Now it's time to find a centrifuge. This will separate uranium-235 from uranium-238 in much the same way a salad spinner separates dense water droplets from lightweight lettuce leaves. But a salad spinner won't come close. To separate tiny atomic masses requires something that can spin at tens of thousands of rotations per minute. Centrifuges are a tough technology to master, and a rogue nation shouldn't expect a lot of help from established nuclear powers. Through a trade organization known as the Nuclear Suppliers Group, they carefully regulate the export of centrifuge parts and designs. Nevertheless, there are ways around the restrictions, according to Joshua Pollack, a consultant to the U.S. government on deterrence and nuclear proliferation. In 2004, the father of Pakistan's nuclear bomb, Abdul Qadir Khan, admitted that he had been at the center of a vast smuggling network that supplied centrifuge designs, parts and expertise to Iran, North Korea, and Libya, among others. Khan's network has since been shut down, but even when running, Pollack says he's not sure it was the best way to get a centrifuge. Khan often supplied cheap, faulty parts and misleading designs to his customers. He was taking Iran and Libya to the cleaners, Pollack says. Given the unreliability of the black market, some countries have established other dubious ways to get their hands on the necessary machinery, such as setting up shell companies in other countries. The North Koreans are just masters of this, Pollock says. For example, according to a report by the Institute for Science and International Security (ISIS), the North Koreans set up a firm in China with the name Shenyang Aircraft Group Dandong Import and Export Co. Limited. The lengthy title was nearly identical to that of a legitimate Chinese firm known as the Shenyang Aircraft Industry Group Import and Export Co., Dandong Branch. The confusion allowed North Korea to import centrifuge parts undetected. Step 5. Enrich. Regardless of how they do it, a country will need several thousand centrifuges. These must be strung together into cascades that can enrich the uranium hexafluoride gas made earlier. By passing the uranium hexafluoride from cascade to cascade, uranium-235 begins to slowly accumulate. Iran has been working on enrichment since the early 2000s and in February 2010 said it had begun processing uranium to 20% enrichment. This has civilian uses but is also a significant step towards producing weapons-grade uranium. It's a tedious process that will take months to complete, and may be slowed by accidents and sabotage. A powerful computer virus called Stuxnet, for example, caused hundreds of Iran's centrifuges to spin themselves apart. However, if a state uses its centrifuges wisely, it can have enough uranium-235 for a bomb in under a year, and the 150 kilograms 330 pounds, needed for 2 or 3 in less than 2 years. Step 6. Get a design. While a country is waiting for its uranium to enrich, it needs to start thinking about bomb design. First, it needs to work out what this nuclear weapon is for. If it wants an object of stealthy terror, or a device that will prop up a shaky regime's domestic reputation, then a gun-type weapon is the most likely way to go. A gun device can be easily fashioned out of an old artillery barrel that will literally shoot 2 near-critical masses of uranium together. It requires more than twice as much material as your standard nuclear weapon, and it can't fit easily onto a missile. But the gun-type weapon is guaranteed to work on first try. If, on the other hand, the regime is looking to build a weapon that could be launched quickly, then an implosion weapon is better. Implosion weapons work by packing explosives around a sphere of uranium-235. Detonating the explosive simultaneously will squeeze the sphere until it reaches a critical mass. To make it work requires precise timing and a hard-to-design neutron detonator that will give the weapon a kick at just the right time. But the advantages of that: an implosion device uses less material and can fit atop a missile. The confusion allowed evidence collected by the International Atomic Energy Agency (IAEA) suggests that Iran has been working on implosion designs. How hard is it to come up with a simple design on your own? Not hard at all, says John Costa Mullen. Costa Mullen is a truck driver from Waukesha, Wisconsin who has devoted his life to reverse engineering Little Boy and Fat Man, the first 2 nuclear weapons ever to be used. His designs are considered credible by the experts and depend only on a knowledge of physics, unclassified material about the bombs and the extensive open literature on nuclear chain reactions. It has taken Costa Mullen 19 years to develop his drawings, but a small team with a physics and engineering background could probably do it in a matter of months. Step 7. Manufacture. At this stage, the wannabe nuclear state may have its design and your enriched uranium-235, but it's still not quite there yet. First, the team of scientists has got to get the uranium out of gaseous form and into a metal. A simple recipe using water, hydrofluoric acid, and magnesium does the trick. With the metal ready, it has to be machined into the desired shape, either 2 halves of a sphere for an implosion weapon, or discs for a gun-type device. But they will have to take care not to work on too much at once, says James Acton, a physicist with the Carnegie Endowment for International Peace. If you screw up at that stage, there's a risk of a criticality accident, he says. It won't be a full nuclear blast, but the explosion will be powerful enough to destroy the workshop and probably give anyone working on the device a fatal dose of radiation. Step 8. Develop a delivery system. A nuclear weapon is no good unless there is a way to deliver it to the enemy, ideally far away from the launch site. States that love nuclear also love missiles, says Jeffrey Lewis. Short-range missiles can be bought from rogue states like North Korea. But long-range ballistic missile technology is tightly controlled, and trying to develop a missile is as or more difficult than building the weapon itself. Intercontinental ballistic missiles must be as lightweight as possible, while still being powerful and accurate, according to David Wright, a ballistic missile expert at the Union of Concerned Scientists. Evidence collected by the International Atomic Energy Agency (IAEA) suggests that Iran has. That makes it very hard to make them work, as demonstrated by the most recent North Korean launch failure in April. Alternatives include stealthy submarine-launched weapons and cruise missiles, which are even more complex, and bombers. That last option, while slow and vulnerable, is probably the best technological bet for an upstart nation. Step 9. Test. Even if a country has built a simple gun-type weapon, it may find it valuable to conduct a nuclear test. These days, tests are done underground to contain radioactive fallout, so it will require digging a hole or finding an abandoned mineshaft that can be backfilled with rocks and gravel. The result won't be a mushroom cloud, but it will still get noticed. The Comprehensive Test Ban Treaty Organization in Vienna runs a sensitive global network of seismometers and radionuclide detectors that can pick up even the smallest nuclear explosions. I think that most states don't really test so much as they demonstrate, says Lewis. Testing one of your weapons sends a powerful message that you are part of the nuclear club, and as such, you demand respect. It may also boost your status in the eyes of your population. That said, not everyone tests. The Israelis, for example, have never officially conducted a nuclear detonation. Step 10. Enjoy the sanctions of your labor. By now the aspiring nuclear nation will have devoted years of effort and many millions of dollars to its nuclear program. You may think that all that work would win accolades, but it's far more likely to get it slapped with some serious penalties. After North Korea conducted its first nuclear weapons test in October of 2006, the UN imposed crippling sanctions that has brought the economy to its knees. Iran, similarly, faces the threat of sanctions if it does not open its nuclear research to international inspectors. I think many countries, perhaps most, are nuclear weapons capable, says government consultant Joshua Pollack. But very few nations have actually bothered to go ahead with weapons development. Pollack believes that's because most states recognize a nuclear weapon will do little to make them safer. The thing about the bomb is that it's not like a tank or a plane. You can't guard your frontiers with it, he says. All you can do is threaten to annihilate the other guy. Thanks for watching. Don't forget to like and subscribe.